All right, coming up here on the end of the enzymes, and we want to talk about regulating enzyme activity. So there's a lot of ways to regulate enzyme activity. In other words, what we're talking about here is the fact that you do not always want enzymes constantly on, right? Enzymes are not always constantly active. This is rather an important concept, especially when you think about homeostasis. Most reactions that enzymes catalyze tend to be one way, right? If you break sucrose down into glucose and fructose using the sucrase enzyme, the sucrase enzyme is not going to take glucose and fructose and put them back together in order to make sucrose again. And so, if you have to have a minimum sucrose concentration, having sucrase just constantly active is bad because it will eventually run you out of sucrose. So, enzymes tend to not be constantly active, which means we often have states where they are either able to be turned on or turned off. Right? So, as far as a natural regulating mechanism for turning something on, turning an enzyme off, allosteric inhibitors. There are naturally produced allosteric inhibitors. So, that's pretty simple. As far as an enzyme that is default off, right, you could have an allosteric activator. Right, so an allosteric activator would be pretty simple. Here's my enzyme with my empty allosteric site. Right, and then we have my substrate. We have my active site. And we have my allosteric site. And then I have an allosteric activator. Boop, boop. And in order to turn my enzyme on, I just need to bind my allosteric activator on there. Ta-da! So now I have my active enzyme. So it's kind of the reverse of allosteric inhibition. In allosteric inhibition, when we talk about non-competitive inhibition, it binds the allosteric site and then alters the active site so that the reactions cannot be catalyzed. An allosteric activator is where you have an enzyme that defaults to the off state and requires an allosteric activator to bind to the allosteric site in order to get to the correct active site conformation. So that's a pretty simple way to regulate enzyme activity. Another way to have enzyme activity regulated is to have an enzyme that requires a separate compound to bind to it in order to correctly catalyze, to have an active site that can catalyze a substrate. So here's my enzyme. And then we'll have just the same gimmick with our substrate. And this enzyme obviously cannot bind to that substrate. So this is my inactive enzyme. In this case, instead of something like an allosteric activator, what it needs is a non-enzyme component that binds to the enzyme in order to allow it to function. So what we have now is a situation where we talk about coenzymes. Okay, so what is a coenzyme? Coenzyme is a non-enzyme chemical structure component. I'm going to say component that binds to the enzyme in order to actually get the correct conformation. That must bind to produce the correct conformation. So, without the coenzyme, the enzyme cannot bind to the substrate. So, in this case, our enzyme activity can be regulated by whether or not we've got our coenzymes made. So you can produce the coenzyme, and that will govern the reaction. So you're going to learn about it in the respiration lecture coming up, the very next lecture after this. But one of the products in respiration is called acetyl CoA, and that CoA stands for coenzyme A. And essentially, that little chemical there is basically an acetyl attached to the coenzyme that will be required for the next set of chemical reactions. So, it'd be like if this would be like acetyl CoA right here. So this is my acetyl, and this is coenzyme A. And then it can then bind at the enzyme and have the reaction catalyzed. That would be an example of a coenzyme being used in order to regulate the enzyme's activity, right? We can't just, the reaction doesn't immediately get catalyzed when you crank out acetyl. You have to have acetyl bonded to a coenzyme A in order to actually get the reaction catalyzed. The coenzyme is required to bind to the enzyme to produce the correct conformation so that we have a functional active site, right? So, required for a functional active site. And that's coenzymes. Not the worst thing in the world there. Lastly, let's talk about feedback inhibition. So this is a incredibly simple way to regulate enzyme activity, and that's to just have a situation where the product of the catalyzed reaction is an inhibitor. Right? Could be competitive, could be non-competitive, but either way, The product is an inhibitor. So if you have, 100 substrate molecules and you have 10 enzymes, right? The more product you get after one cycle, you'll have 90 substrate, 10 products, and 10 enzymes. And you'll start getting this, 9-to-1 chance that a substrate versus an inhibitor will bind. And so maybe now you get, 85, like 5 substrate bind and 5 inhibitors bind. And so now you have that, and then you're down to 5 enzymes. And so the more product you get, the more enzymes are inhibited. So in this case, right, we can, instead of me just applying random numbers that aren't always helpful for people, think of it, we have our competitive inhibition thing here, right? So this was enzyme activity, or sorry, this was inhibitor concentration. And this is enzyme activity. So the more inhibitor, the lower the enzyme activity. Well, in this case, the more product, the lower the enzyme activity. So catalyzing the reaction starts to regulate the rate of reaction. The more product that we have, the lower those enzymes are, the lower reaction rate you're going to see as more and more of those enzymes become inhibited by the product. And it's pretty much that simple. It's like an extremely simple method for regulating enzyme activity. Just have the product be the inhibitor. So, there's your enzyme. And you got your substrate. And then when your reaction is catalyzed, you get your products. And the product is an inhibitor, right? And so if it binds to the active site of the enzyme, then it won't catalyze any more reactions. So, pretty simple. They can be, feedback inhibition does not imply competitive or non-competitive. It could be either. It's just the product is the inhibitor. So more product means decreased enzyme activity, because more product means more enzymes are binding to the inhibitors, which means fewer enzymes are active. And that's pretty much all I wanted to talk about with enzyme regulation. So hopefully this wasn't so painful, and that also closes out enzymes. So you are now prepared for cellular respiration and or an exam. Woo!